In today's video, I am going to explain about quarks model. Quarks are nothing but the fundamental particles with no internal structure. There are six types of quarks that are up quark, down quark, strange quark, charm quark, top quark, and bottom quark. Yes, and the representation of these quarks are given below here. That is U, D, S, C, tau you can call it as, and B respectively. Yes, we have six type of quarks. That is, again I am explaining: up quark, down quark, strange, charm, top, and bottom. But usually we will be using these three fundamental particles. Fundamental particles means these particles cannot be divided further and that don't have internal structure as well. Yes, next we will be moving to the next slide called Quark's model representation. Yes, in the last video, I have explained about the meson octet structure, baryon octet, and baryon decouplet. There I have explained about the spin, isospin, strangeness, charge, and the third component of the isospin, as well as lepton number and baryon number. Here also we will be seeing the fundamental particles charges. So here up quark will be having the charge q, which is equal to 2 by 3 e is a charge of an electron. Down quark and strange quark, which is having a charge q, which is equal to minus 1 by 3 times of e, and it has the spin half and half. Isospin for up and down it is 1 by 2, and for strange quark it is 0, and strangeness for up and down it is 0, and for strange quark it is minus 1. It has the baryon number b, which is equal to 1 by 3. It is represented by the symbol b. Okay, yes, and the third component of the isospin I am representing here by the symbol I3. The third component of the isospin for down quark it is half, up quark minus 1 by 2, and the strange quark is 0. Yes, and the next model we are going to deal with the anti-quark model. Okay, anti-quarks are represented by the symbol bar. I have written here. So it is S bar, U bar, and D bar. Okay, for anti-quarks, one thing we need to remember in mind, that is charge, strangeness, baryon number, and third component of the isospin changes for antiquarks. Yes, so I3 is here 0, minus 1 by 2, half for strange quark, down quark, and up quark respectively, that is antiparticles. Spin for anti, strange, and the anti down, anti up quark is half and half, it remains the same. Isospin also remains the same, whereas the strangeness here it is S bar. For S bar it is half, for U bar and D bar it is 0. Okay, next the baryon number is also changes, means it will be minus 1 by 3. Here also it will be minus 1 by 3 for strange, anti-strange quark, anti down quark, and anti up quark. Next we will be moving to the next slide called quark configuration for mesons and baryons. In my previous video I have explained about the meson particle and also the baryon particles. See here, pi positive, pi negative, pi 0, eta 0, k 0, k positive, k negative, k negative 0. These are nothing but my mesons. For every mesons we have the respective quarks combination. See, one thing we need to keep here in mind, that is mesons have combination of quark and antiquark. Yes, it is a combination of two quarks, that is one is a quark and one is a antiquark. Yes. For pi positive it is U D bar. We will be equivalating. We will be seeing how it is. So pi positive means it is having the charge positive, right? So how it will be U D bar means, see, for up quark the charge is 2 by 3 times of E. For down quark the charge is minus 1 by 3 times of E. So do the normal subtraction. So 2 minus 1 it will be 1, and here one more thing, it is D bar, no, it is anti quark. So For down quark, it is minus 1 by 3. For anti down quark, it is plus 1 by 3. That we need to keep in mind. On adding these two, it will be 3e by 3. So 3 get cancels, the charge is plus e, so positive. So here also we have a positive, and here also we got the positive. That is how it works. Likewise, pi negative as u bar d, and pi 0 and eta 0, it is d d bar, u bar, and s bar. And why we here we are not using s bar or s means pi doesn't have a strangeness. Its strangeness is 0. So k0, k positive, k negative, and k negative 0, all these four particles, that is k mesons, have strange number. That why the strange quark came into the existence. Likewise, we have for baryons, these 10 particles are the baryons. Okay, for neutron, it is UDDY, 3 particles, means baryons are combination of 3 quarks. That's why it is 3 particles. Yes? Yes. Now we will be proving for 1. So let us prove for this neutron. Neutron means it is neutral in charge. So charge should be equal to 0, right? See, it is a combination of U, D, D. For up quark, we have a charge 2 by 3 times of E. For down quark, we have a charge minus 1 by 3 times of E. Again, we have a down quark, it is minus 1 by 3 times of E. So on subtracting, take the LCM of 3. 2 minus 1 minus 1, it is 2 minus 2 times of E. So 2 minus 2, it is again 0. 0 by 3 times of E is 0. Okay, so we got the answer. The charge for a neutron is 0. That is neutral, it is 0. I hope you people understood how it works. So for proton, it is UUD. For sigma negative, DDS. Sigma positive, UDS. Sigma 0, UUS. Cascade negative, DSS. Cascade 0, USS. Lambda 0, USS. Delta plus plus positive, it is UUU, and omega negative, it is SSS. Based on this only, the problems arise from the KSET examination. Now we will be solving problems one by one, which was asked in the KSET. Yes, we will be taking the problem number 1. According to the standard model of particles, which one of the following is a fundamental particle, which was asked in the year recently, it is 2024. Okay, so what does the question says? According to the standard model of particles, which one of the following is a fundamental particle? What is fundamental particles? Fundamental particles are nothing but the quarks, right? Like pi meson. Mesons are the quarks model. Quarks, it is a combination of quarks. That is a combination of quark and antiquark. Deuteron, no. Muon, no. These belongs to the lepton. And neutron also, uh, it belongs to the uh, quarks also. So we can take both the option, that is option 4 is also correct, and option 1 is also correct. Both the option correct here. I don't know which they have given. So here neutron is also correct option, and pi meson is also correct option. I'll go with the neutron. Okay. Yes. Next question. In case of a fundamental particles, conservation of energy is obeyed, conservation of momentum is obeyed, but angular momentum is not obeyed. Conservation of parity is not obeyed, and the conservation of isotopic spin is obeyed. So which of the options is correct, that they are asking? Okay, so fundamental particles means conservation of energy is obeyed. This is the correct option. Conservation of momentum as well as angular momentum, both are obeyed. So this will be the wrong option. Conservation of parity is not obeyed. They have given conservation of parity is obeyed, and the conservation of isotopic spin is obeyed. So this is the correct option. It is a combination of 1 and 4. Option D is right. Okay. Yes. Next, we will be moving on to the next slide and next question. The quark composition of proton and neutron are? This was asked in the year 2013, this question. And this in the previous slide, this question was asked in the year 2014. Okay, so this question now in this slide, this question was asked in the year 2030. The quark composition of proton and neutron respectively, it is in our previous slide only. We can see proton, let us represent it by the symbol P, and the neutron, it is represented by the symbol N. Let us see proton, it is a combination of UUD, neutron, it is a combination UDD. Okay, so proton, it is a combination of what? Proton, it is a combination of UUD, and the neutron is a combination of UDD. Let us see which option is correct. Here option B. See, proton is a combination of DUU. We can interchange and write it as one and the same, and here it is neutron, it is DDU. So option B is the right answer. I hope everyone it is clear with this question. Like this type of a question they are asking from all the years. Yes. Let us move to the next question. The 73rd question, which was asked in the year 2015. Which of the following as an internal structure? Internal structure is nothing but again, from the definition I can say fundamental particle. Photon, no. Muon, electron, and pion. Muon, it belongs to the leptons. Electron, no. Pion is the right answer. So it is also the direct question. So option D is the right answer. Let us move to the next slide and the next question, 54th question, which was asked in the year 2017. Okay, so this is also easy question, and it is from the quark composition again. We have a K meson, that is K positive, K0, pi positive, and pi 0. Let us solve this question. K positive, let us look here. K positive, it is a quark configuration, it will be US bar. So US bar for K positive, what it is? K positive is US bar, that is option B. Next, for K0, let us go back to the slide and see. For K0, it is DS bar. Okay, for K0, it is DS bar. DS bar, that is where it is option D. Likewise, pi positive. Pi positive is what? And pi 0. Pi 0, it will be, let us see pi 0. Let us go back to the third slide and see. Pi 0, it is DD bar, UU bar, or SS bar. Let us see where it is. The option UU bar minus DD bar 1 by square root of 2. This is also the correct option. So for pi 0, it is option C, I can say. Option C, that is 1 by square root of U bar minus D bar. That is option C. Next, pi positive, it will be the remaining option. What is the remaining option? UD bar. We will go back to the slide and see. Pi positive is UD bar. Yes, our answer is correct. Now let us match the following. Okay, so first will be B, B, D, then C, C, and this is A. C, this is A. First it is pi positive. No, pi positive, it is A, and it is C. It is C. Yes. B, D, A, C. So the third option is here correct. We'll be ticking to the third option, and these are the easiest questions you can solve looking at the third slide. Every question is solved by the third slide itself. Yes. Now we will be moving on to the next question. I hope everyone is clear with this question. We will be moving on to the next question, which was asked in the year 2020. Recently, it was asked the quark contents of delta positive and proton. Delta positive is a baryon and proton is also a baryon. The proton, they have asked this question second time, I think. Let us move proton. Uh, move back to the third slide. Proton, it is a combination of UUD. Okay, go back to the question. Proton, it is a combination of UUD. So if we know one, we can also find for delta positive UUD. In only one option you have UUD, directly you can take for delta positive and proton, both it is having UUD only, because delta positive charge is what? Plus 1. What is the charge of a proton? It is again the plus 1. Both are having the same quark composition. I hope everyone, these are the questions which was asked previous from the previous KSET examination. I hope this quark model is very easy and everyone can understand, everyone can get 2 marks in your pockets. Thank you everyone.